Yeah, even Telegram link will not work. I have deleted those two channel, Discord and Telegram. Circulation. Hi विराट, लेट्स नॉट टॉक ओके. मैं चैट्स ऑफ कर देती हूँ, 50 मिनट का सेशन लगा देती हूँ. एक्सक्यूज मी. इनका बिनिंग हो गया है तो breathing process of exchange of O2 from the atmosphere with CO2 produced by the cell. Respiration, catabolic reaction, breakdown of glucose. Sponges, cylindrate, flatworm, etc. Exchange O2 by simple diffusion. Sponges, cylindrate, flatworm. Sponge, cylindrate and flatworms. Platyhelminth means this simple diffusion. Earthworm use their moist cuticle. Insects have a network of tracheal tubes to transport atmospheric air within the body. Spherical vascularized structure called gills are used by most of the aquatic arthropods. Special vascularized structure called gills are used by most of the aquatic arthropods and mollusks. Vascularized structure called gills. Gills, aquatic arthropods and mollusks. Whereas vascularized bag called lungs are used by terrestrial form for the exchange of gases. Okay, terrestrial form. Aquatic arthropods and mollusks. Vascularized bag. Aquatic arthropods. Vascularized bag. Earthworm moist cuticles. Insect network of tracheal tubes. Normal. Amphibians, okay. Among vertebrates, fishes use gills, whereas reptiles, birds, and mammal respire through lungs. Even reptiles, okay? Reptiles, birds, and mammals respire through lungs. Amphibians like frog can respire through their moist skin also, okay? Moist skin. Amphibians like frog, moist skin. Mammals have a well-developed respiratory system, okay? Simple diffusion. Diffusion through body surface, right? Simple diffusion through body surface. Yes. Simple diffusion through body surface. Body surface. These are porifera, coelenterata, and porifera, coelenterata, and what was that? Porifera, coelenterata, and flatworms. Okay, platyhelminthes, flatworms, sponges, coelentrates, and flatworm, platyhelminthes. Flatworms, they respire through simple diffusion across over their entire body surface. Earthworm, EARTH, earthworm uses moist cuticles. Insects have tracheal network of tracheal tube network of tracheal tube. Mollusk and aquatic insects. Mollusk and aquatic insect, they use gills, right? Now vascularized a structure called gills used by most aquatic arthropods and mollusk. Excuse me. Lungs by terrestrial form. Reptiles, birds, and mammals. Fishes, gills. Amphibians like frog. Moist cuticles, again moist skin. Frog. Amphibians like frog. Moist skin, MOIST, moist skin. Larynx, sound box, cartilaginous. Sound production, sound box. Cartilaginous box which helps in sound production and hence called sound box. Okay, first nostrils, nasal passage, and then nasal chamber. Nasal chamber is open into pharynx. Nasal passage. Okay, it leads to nasal chamber through nasal passage, pharynx, and then larynx, trachea. Pharynx, larynx, and trachea. Fifth, thoracic vertebra. Pleural fluid reduces friction. Outer pleura is in contact with thoracic. कहाँ गया? The outer pleura is in close contact with the thoracic lining, whereas inner pleural membrane is in contact with lungs. Vascularized bag-like structure called alveoli. Okay? Each bronchi undergoes division, secondary, tertiary bronchi, and bronchioles, ending up in very thin terminal bronchioles. Cartilaginous ring. The trachea, primary, secondary, and tertiary bronchi, and initial bronchioles are supported by incomplete cartilaginous ring. Bronchus, cut end of ribs, lungs, diaphragm, heart, pleural membrane, alveoli, pleural fluid, bronchioles, trachea. Human respiratory system, diagrammatic view of human respiratory system. Okay. Such as arrangement is essential for breathing as we cannot directly alter the pulmonary volume. Airtight chamber, anatomically airtight chamber. Lungs are situated in the thoracic chamber, which is anatomically an airtight chamber, thoracic chamber. Okay. Breathing or pulmonary ventilation, by which atmospheric air is drawn in and CO2 rich alveolar air is released out. Diffusion of gases O2 and CO2 across alveolar membrane. Transport of gases by the blood. Diffusion of O2 and CO2 between blood and tissue. Utilization of O2 by the cells for catabolic reaction and resultant release of CO2. Cellular respiration. Inspiration. Inspiration 0.2 seconds. Expiration 0.3 seconds. 2 and 3 seconds. Inspiration 2 seconds. Expiration 3 seconds. Creating a pressure gradient between lungs and atmosphere. Inspiration can occur if the pressure of the atmosphere is higher than the intrapulmonary pressure. If the pressure within the lungs, intrapulmonary pressure, is negative, less than the atmospheric pressure. If there is negative pressure in the lungs with respect to atmospheric pressure. More pressure on lungs. When the intrapulmonary pressure is higher than that of the atmospheric pressure, expiration. External diaphragm and the spatial set of muscles, intercostal muscles, external intercostal muscle and internal intercostal muscle. External and internal intercostal muscles between the ribs helps in generation of such gradient. Diaphragm, intercostal muscles. Inspiration is initiated by the contraction of diaphragm. Contraction of diaphragm, which increases the volume of thoracic chamber. Anterior-posterior region. In anterior-posterior axis. Anterior-posterior axis. Contraction of diaphragm. Contraction of diaphragm, volume increases. In thoracic chamber, volume of thoracic chamber in anterior-posterior axis. The contraction of external intercostal muscles lifts the ribs and sternum up, increasing the volume in dorsoventral axis. The muscle lifts up the ribs, external intercostal muscles. Increase in volume of thoracic chamber in dorsoventral axis. Intrapulmonary pressure, atmospheric pressure. Relaxation of diaphragm and the intercostal muscles returns the diaphragm and sternum to normal position, reducing the volume in anterior-posterior region and dorsoventral. Returns diaphragm and sternum to normal position and intrapulmonary pressure to slightly above the atmospheric pressure. With the help of abdominal muscle, additional muscles in the abdomen. It's 12 to 16 times per minute. 12 to 16 times per minute. 12 to 16 times per minute. The volume of air involved in breathing movements can be spirometer. 12 to 16 times per minute. Healthy human breathes, okay? Ribs and sternum raised. Volume of thorax increase. Diaphragm contract. Air entering lungs. Air expelled from lungs. Ribs and sternum return to original position. Diaphragm relaxed and arched upward. Volume of thorax decreases. Expiration. Tidal volume 500. Tidal volume is equals to 500 ml. Tidal volume, IRV, inspiratory reserve volume, 2500 to 3000 ml. ERV 1100 to 1200, and RV, residual volume is 1200 ml. ERV 1000 to 1100, okay, 1000 to 1100, 1000 ml to 1100 ml. Expiratory reserve volume. Tidal volume, volume of air inspired or expired during a normal respiration. Volume of air inspired or expired during a normal respiration. It is approx 500 ml. Healthy men can inspire or expire approximately 6000 to 8000 ml of air per minute. 6000 to 8000 ml of air per minute. Inspiratory reserve volume, IRV, additional volume of air a person can inspire by a forcible inspiration, 2500 ml to 3000 ml. Expiratory reserve volume, ERV, additional volume of air a person can expire by a forcible expiration. This varies from 1000 to 1100 ml. 12 to 16 times per minute. Six thousand to 8000, okay, 6000 to 8000 ml of volume of air remaining in the lungs even after a forcible expiration. This averages from 1100 to 1200 ml. Here, RV residual volume, 1100 to 1200 ml. Volume is respiratory capacities. Residual volume can't measure by spirometer. Residual volume prevent the alveoli from collapsing. Excuse me. मैं थोड़ा सा पानी लेके आई, ओके? खानु न भने Inspiratory capacities. Inspiratory capacity, total volume of air a person can inspire after a normal expiration. Total volume of air a person can inspire after a normal expiration. This includes tidal volume plus inspiratory reserve volume. Okay, expiratory capacity, volume of air a person can expire after a normal inspiration. Tidal volume plus expiratory reserve volume. Functional residual capacity, FRC, volume of air that will remain in lungs after a normal expiration. This includes ERV plus RV, residual volume. ERV, expiratory reserve volume plus residual volume. Functional residual capacity, FRC, can't be measured with spirometer. Prevent alveoli from collapsing. Residual volume. Functional residual capacity, FRC, volume of air that will remain in the lungs after a normal expiration. This includes tidal volume This includes not tidal volume, ERV, ERV, expiratory reserve volume, and RV, residual volume. Vital capacity. The maximum volume of air a person can breathe in after a forced expiration, tidal volume, expiratory reserve volume, and ERV. This includes ERV, TV, and IRV, or the maximum volume of air a person can breathe out after a forced inspiration. Expiratory reserve volume, tidal volume, and inspiratory reserve volume. Okay. Total lung capacity. Total volume of air recommended in lungs at the end of a forced inspiration. RV, ERV, tidal volume, and the IRV, or residual volume plus vital capacity. Residual volume plus vital capacity. Okay, इसका तुम्हें ट्रिक बनाना पड़ेगा ना, वरना तुम भूल जाओगे. Inspiratory reserve volume, IRV, equals to IRV, TV, tidal volume 500 ml, IRV 2500 ml to 3000 ml, IRV. Inspiratory reserve volume. Expiratory reserve volume is equals to 1000 ml to 1000 1100 ml. 1100 ml, 1000 to 1100 ml, ERV, expiratory reserve volume. Then we have residual volume. Residual volume 1100 ml to 1200 ml. Inspiratory reserve volume, expiratory reserve volume, and residual volume. Tidal volume is equals to 500 ml. Capacities. First we have inspiratory capacity is equals to tidal volume plus inspiratory reserve volume. Expiratory capacity is equals to tidal volume plus expiratory reserve volume. 1, 2. Functional residual volume. Functional residual volume is the volume of air that remains in lungs after a normal inspiration or expiration. I think it's expiration. Normal expiration. They have residual volume plus expiratory reserve volume. Residual volume plus expiratory reserve volume. Vital capacity. Tidal volume, inspiratory reserve volume, and expiratory reserve volume. Finally, total lung capacity. Total lung capacity, VC plus RV. Vital capacity or vital capacity plus residual volume or tidal volume, IRV. Inspiratory reserve volume, expiratory reserve volume, and vital capacity. Total lung capacity. Okay. Residual volume, functional residual volume, and total lung capacity cannot be measured. We can't measure it with spirometer. Alveoli are the primary site of exchange of gases. Primary site of exchange of gases. Okay. Exchange of gases, blood and tissue. Exchange of gases between blood and tissue. Oxygen. Simple diffusion. Simple diffusion. Exchange of gases. Simple diffusion between blood and tissue. Mainly based on pressure, concentration gradient. Pressure, concentration gradient. Solubility of gases depends on thickness of membrane. Mhm. Solubility of gas depends on thickness of membrane involved in diffusion are also important. Okay, thickness of membrane in diffusion are also important factor that can affect rate of diffusion. Rate of diffusion depends on thickness of the membrane and solubility of gases. Solubility of gases and thickness of membrane is important for rate of diffusion. Thickness of membrane, solubility of gases. Pressure contributed by an individual gas in a mixture of gases is called partial pressure. Pressure contributed by individual gas. Pressure contributed by an individual gas. Pressure, individual gas, mixture of gases. In mixture of gases. Okay. Pressure contributed by single gas. Pressure contributed by individual gas in mixture of gases called partial pressure. Pressure contributed by an individual gas in a mixture of gases is called partial pressure and is represented by partial pressure of oxygen, partial pressure of carbon dioxide. Pressure contributed by individual gas in a mixture of gases called partial pressure by and is represented as partial BO2 for oxygen and BCO2 for carbon dioxide. Concentration, okay, solubility of gases, thickness of the member, rate of diffusion of gases. Respiratory gases. Respiratory gas, oxygen and CO2. ATM, atmospheric air, pressure of O2. PO2 is equals to partial pressure of O2 is 159 mmHg. Partial pressure of CO2. Partial pressure of CO2 0.3 mmHg. 159 okay, alveoli and then alveoli. Partial pressure of partial pressure of CO2 alveoli 40 mmHg. 103 mmHg in alveoli. Partial pressure of oxygen 104 mmHg 40 mmHg 104 mmHg in alveoli. Partial pressure of oxygen 104 mmHg. 104 mmHg, 40 mmHg. Then we have deoxygenated blood. Partial pressure of O2 and deoxygenated 40 deoxygenated 40 mmHg. Partial pressure of carbon dioxide 45 mmHg. Oxygenated blood. Partial pressure of O2 is equals to 95 mmHg. Partial pressure of carbon dioxide is 40 mmHg. Oxygenated blood 95 mmHg and 40 mmHg. Tissue. Partial pressure of O2 40 mmHg in tissue. Partial pressure of CO2 is 45 mmHg and 40 mmHg. Diagrammatic representation. Diagrammatic representation of exchange of gases at alveolus and body tissue, exchange of gases at alveolus body tissue with blood and transport of oxygen and carbon dioxide. Inspired air, expired air. Alveolar air, partial pressure of oxygen 104 mmHg, partial pressure of carbon dioxide 40 mmHg. Alveolus. Pulmonary vein, oxygenated blood. Pulmonary vein, oxygenated blood. Left ventricle, left atrial, left ventricle. Aorta. Systemic arteries. Systemic arteries or aorta. Carrying oxygenated blood. Partial pressure of oxygen 95 mmHg. Oxygenated blood. Partial pressure of carbon dioxide 40 mmHg. Partial pressure of oxygen here 40 mmHg. 95, 45 and 40. Systemic vein, carrying deoxygenated blood. Partial pressure of oxygen 40 mmHg. Partial pressure of carbon dioxide 45 mmHg. Right atria, right ventricle. Pulmonary artery. Pulmonary artery. A gradient is present for carbon dioxide in opposite direction. Tissue to blood. Blood to alveoli. Tissue to blood and blood to alveoli. The solubility of CO2 is 20 to 25 times higher than that of oxygen. Solubility of CO2 is higher than oxygen, 20 to 25 times. Solubility of carbon dioxide is higher than oxygen. Three major layer. Squamous epithelium of alveoli, basement membrane, endothelium of blood capillaries. Thin squamous epithelium of alveoli, endothelium of alveolar capillaries, and basement membrane, less than 1 millimeter. Endothelium of alveolar capillaries. Thin squamous epithelium and alveoli, basement substances. Diffusion of O2 from alveoli to tissue. And that of CO2 from tissue to alveoli. Diffusion of CO2 from tissue to alveoli. Transport of gases. RBC carries oxygen maximum. 97% of oxygen is transported by RBC in blood. Remaining 3% O2 is carried by blood plasma. Dissolved state through plasma is carried in a dissolved state through the plasma. Okay, blood is the medium of transport for O2 and CO2. Oxygen and carbon dioxide. %97% of O2 is transported by RBC. Remaining 3% O2 is carried in a dissolved state through plasma. 20 to 25% CO2 is imported by RBC, whereas 70% of it is carried as bicarbonate. Percent of CO2 is transported by RBC. 20 to 25% of CO2 is transported by RBC. 20 to 25% of CO2 is transported by RBC, whereas 70% of it is carried as bicarbonate ions. 20 to 25%. 97% O2 is transported by RBC of the blood. Dissolved state through plasma. Dissolved state, plasma, RBC, hemoglobin. Okay. Nearly 20 to 25% CO2 is transported by RBC, whereas 70% is carried as bicarbonate. 7% of CO2 is carried in a dissolved state through plasma. CO2 transport. 70% bicarbonate. Is it bicarbonate? I guess so. 70% bicarbonate, 2%, 7% of 20 to 25% RBC, 7% dissolved state in plasma. Transport of RBC. Transport of O2 के RBC. Transport O2. 97% by RBC. 3% dissolve state. Plasma. Dissolved state in plasma. Plasma 20 to 25% CO2. Bicarbonate 7%. Dissolved state through plasma. Red color, iron containing pigment. Iron containing pigment. Oxygen plus hemoglobin. Oxyhemoglobin. Oxygen plus hemoglobin. Oxyhemoglobin. They are reversible. Reversible. Binding of oxygen and hemoglobin is reversible. Each hemoglobin molecule can carry maximum 4 molecules of O2. HB carries max 4 molecules of O2. Binding of partial pressure of O2. Partial pressure of CO2, hydrogen ion concentrate and temperature are other factors which can interfere with the binding. Sigmoid curve is obtained when percentage saturation of hemoglobin with oxygen. Percentage saturation of hemoglobin with oxygen is plotted against the partial pressure of O2. Percentage saturation of oxyhemoglobin with O2 is plotted against the partial pressure of oxygen. Sigmoid curve, percentage saturation of hemoglobin with oxygen. Percentage saturation of hemoglobin with oxygen against partial pressure of oxygen. Partial pressure of oxygen, percentage saturation of Hb with oxygen. Oxygen dissociation curve, sigmoid curve. Oxygen dissociation curve. Percentage saturation of oxygen, oxyhemoglobin or hemoglobin with oxygen. Percentage saturation of hemoglobin with oxygen. Percentage saturation of hemoglobin with oxygen. Partial pressure of oxygen. Partial pressure of oxygen. Percentage saturation of hemoglobin with oxygen. Percentage saturation of hemoglobin with oxygen. Sigmoid curve. Sigmoid curve. Okay. Partial pressure of oxygen. Partial pressure of carbon dioxide. Hydrogen ion concentration and temperature. Partial pressure of oxygen, partial pressure of carbon dioxide, hydrogen ion concentration and temperature are the major factor. Oxygen dissociation curve. Studying the effect of factors like partial pressure of carbon dioxide, hydrogen ion concentration, etc. on binding of O2 with hemoglobin. Partial pressure of carbon dioxide, H plus concentration, etc. on binding of O2 with hemoglobin. In the alveoli, where there is high partial pressure of alveoli, high partial pressure of oxygen, low partial pressure of carbon dioxide, low hydrogen ion concentration and lower temperature. Lesser hydrogen ion concentration and lower temperature. Everything is lower except partial pressure of oxygen. High partial pressure of oxygen, low partial pressure of carbon dioxide, lesser hydrogen ion concentration and low temperature. Oxyhemoglobin. Low partial pressure of O2, high partial pressure of carbon dioxide, high hydrogen ion concentration and more hydrogen ion concentration and high temperature. High partial pressure of CO2, high H plus concentration and higher temperature exist. The conditions are favorable for dissociation of oxygen. Tissue mounts है okay. Whereas in tissue, अभी को क्या हो alveoli में हो in tissue low partial pressure of oxygen, high partial pressure of CO2 40 and 45. High H plus concentration and higher temperature exist. Dissociation of oxygen from the oxyhemoglobin. The long surface and gets separated or dissociated in tissue. Gets bound to hemoglobin in the lungs surface and gets dissociated at the tissue. 100 ml of oxygenated blood, 5 ml of oxygen. Every 100 ml of oxygenated blood can deliver around 5 ml of oxygen to the tissue. 100 ml of oxygenated blood, 5 ml of O2 to the tissue under normal physiological condition. Five ml of oxygen. CO2 is carried by hemoglobin as carb amino hemoglobin. Carb amino hemoglobin. Carb amino hemoglobin. Oxyhemoglobin, carbon dioxide plus hemoglobin, carb amino hemoglobin. Carb amino hemoglobin. 20 to 25%, okay. Carb amino hemoglobin. Partial pressure of carbon dioxide. Partial pressure of O2 is major factor which could affect this binding. Dissociation of carbon dioxide from carb amino hemoglobin takes place. CO2, which is bound to hemoglobin, forms the from the tissue is delivered at the alveoli. RBC contain very high concentration of RBC. Red blood cells contain very high concentration of an enzyme called carbonic anhydrase. Carbonic anhydrase, correct. Enzyme carbonic anhydrase. Very high concentration of carbonic anhydrase. RBC contain high concentration of carbonic anhydrase. High partial pressure of oxygen is low as in the tissue. More binding of carbon dioxide occurs with dissociation. Carb amino hemoglobin. Minute quantities of the same is present in the plasma too. RBC contain a very high concentration of enzyme carbonic anhydrase. Minute or minute quantities of same carbonic anhydrase is present in plasma too. This enzyme facilitates the following reaction in both the direction: carbon dioxide plus hydrogen carbonate or bicarbonate, right? ना water पहले बनेगा ना. CO2 plus water, carbon dioxide plus water, carbonic acid, H2CO3, H2CO3, carbonic acid in the presence of carbonic anhydrase. Excuse me, bicarbonate, HCO3 minus. Carbon dioxide plus H2O in the presence of carbonic anhydrase. Anhydrase gives carbonic acid H2CO3. Carbonic acid, which is a reversible reaction. And again, H2CO3 in presence of carbonic anhydrase gives HCO3 minus hydrogen bicarbonate, hydrogen carbonate or bicarbonate, and this is H plus, HCO3 minus bicarbonate. It is again reversible, okay? Carbonic acid. At the tissue site where partial pressure of carbon dioxide is high due to catabolism, RBC in plasma and forms diffusion to blood and forms hydrogen carbonate or bicarbonate. Released out as CO2. Every 100 ml of deoxygenated blood carry 4 ml of Carbon dioxide. Every 100 ml of deoxygenated blood delivers approximately 4 ml of CO2 at to the alveoli. Deoxygen from tissue to alveoli. 5 ml of O2 to the tissue. टिश्यू ला पड़ेंगे के एल्वेलाई देखिए टिश्यू में पड़ेंगे टिश्यू देखिए एल्वेलाई में पड़ेंगे CO2 4 ml delivers okay. Then and moderate the respiratory rhythm. Medulla region of the brain called respiratory rhythm center. Medulla region, respiratory rhythm center. Medulla region, respiratory rhythm center. Pneumotaxic center, respiratory rhythm center. Pneumotaxic center, pons, hindbrain. Pneumotaxic center, medulla oblongata. Pneumotaxic center can moderate the function of respiratory rhythm center. Neural signs from this center can reduce the duration of inspiration. Okay. Respiratory rhythm center, medulla oblongata, is primarily responsible for this regulation. Another center present in the pons region of the brain is pneumotaxic center can moderate the function of the respiratory rhythm center. Pneumotaxic center can moderate the function of respiratory rhythm center. Neural signals from this center can reduce the duration of inspiration. Pneumotaxic center, neural signal from the center can reduce the duration of inspiration, and thereby alter the respiratory rate. A chemosensitive area is situated adjacent to the rhythm center. Respiratory rhythm center. Adjacent to respiratory rhythm center, chemosensitive area, highly sensitive to CO2, highly sensitive to carbon dioxide, hydrogen ion, highly sensitive to carbon dioxide and hydrogen ion. Increase in this substance can activate the center, which in turn can signal the rhythm center to make necessary adjustment in the respiratory process, by which these substances can be eliminated. Receptors associated with aortic arch and carotid artery. Aortic arch and carotid artery also can recognize change in carbon dioxide and H plus concentration. Receptors associated with aortic arch and carotid artery. The rhythm center for remedial action. Regulation of respiratory rhythms is quite insignificant. The role of oxygen in the regulation of respiratory rhythm is quite insignificant. Not important, okay? Regulation of respiratory rhythm, role of oxygen, quite insignificant. Insignificant role of oxygen in regulation of respiratory rhythm. 10 minute का break लेंगे, okay? One, two, three, four, five, six, seven, 8, 9, 10. Slot 1 is over. Hi Sharma, Shubham Sharma. हाइमक्री का जालन। खूब सारा पानी लेके आऊंगी, ओके, ताकि मुझे नींद आए। कब तक पढ़ोगी इमा? ये 3 स्लॉट तो कंप्लीट कर ले, अभी 1 स्लॉट कंप्लीट किया है। 10 मिनट का ब्रेक लेंगे, फिर 2 स्लॉट और कंप्लीट करेंगे। आई थिंक 9 तक पढ़ेंगे ना, मैंने कब तक का लगाया है? 9 तक। मैंने पूरा कॉफ़ी पिया है। आई थिंक मुझे नींद नहीं आएगी, हालांकि मैं ठीक से नहीं सोई हूँ। हाय आदर्श। इतना साल से देख slot to 60 minutes. बढ़िया हूँ आदर्श। स्लॉट टू स्टार्ट करते हो कि 10 मिनट का ब्रेक तो ख़त्म हो गया। हाँ, मैंने शायद उनको टीज़ किया ये उनको पसंद नहीं आया, लेकिन मेरा इरादा नहीं था उनको करने का, लेकिन उन्हें बुरा लगा तो मैं क्या ही कर सकती हूँ। तुम अपना इंटेंशन प्योर रखना, बाकी किसको कुछ भी समझ में आए, क्या ही कर सकते हैं। दिल के दर्द दिल। गाना मत गाओ प्लीज, इसको हाइड कर देते हैं। छोड़ो, गाना मत गाओ, कितनी बार बोलूं, एक चीज सुनाई नहीं देती। A spatial center present in the medulla region of brain called respiratory rhythm center is primarily responsible for regulation. Another center present in pons region of the brain called pneumotaxic center can moderate the function of respiratory rhythm center. Respiratory rhythm center का functions कौन रेगुलेट करता है? रेस्पिरेटरी रिदम सेंटर का फंक्शंस के रेगुलेट करता है न्यूमोटैक्सिक सेंटर, जो कि पॉन्स रीजन में होता है. अनदर सेंटर प्रेजेंट इन पॉन्स रीजन ऑफ ब्रेन कॉल्ड न्यूमोटैक्सिक सेंटर कैन मॉडरेट द फंक्शन ऑफ रेस्पिरेटरी रिदम सेंटर. Neural signal from this center can reduce the duration of inspiration and thereby alter the respiratory center present in medulla region of the brain for this regulation. Another center present in pons region of the brain called pneumotaxic center can moderate the function of respiratory rhythm center. Neural signal from this center can reduce the duration of inspiration and thereby alter the respiratory rate. Pneumotaxic center can moderate the function of network. Pneumotaxic center can moderate the function of respiratory rhythm. Another center present in pons region of brain called pneumotaxic center can moderate the function of respiratory rhythm center. Neural signals from this center can reduce the duration of inspiration and thereby alter the respiratory rate. A specialized center present in the medulla region of the brain called respiratory rhythm center is primarily responsible for regulation. Another center present in the pons region of the brain called pneumotaxic center. Another center present in the pons region of the brain called pneumotaxic center can moderate the function of the respiratory rhythm center. Functions of respiratory rhythm center is moderated by pneumotaxic center, which is in pons region. Neural signal from the center can reduce the duration of inspiration. Neural signal from this center, pneumotaxic center, can reduce the duration of inspiration, can increase or reduce the duration of inspiration, and thereby alter the respiratory rate, Hmm. Decrease the respiratory na decrease the inspiration rate, reduces inspiration time or something like that, duration of inspiration, reduces the duration of inspiration and thereby alter the respiratory rate, reduce the duration of inspiration and thereby alter the respiratory rate. I hate her, please छोड़ दे, कोई बात नहीं. Alter the respiratory rate. Chemosensitive area is situated adjacent to rhythm center, which is highly sensitive. Chemosensitive area is highly sensitive to carbon dioxide. Increase in carbon dioxide, which in turn can signal the rhythm center. Chemocenter. The substance can activate the center, which in turn sensitive to CO2 and hydrogen, and which in this increase in the substance can activate the center, which in turn can signal the rhythm center to make necessary adjustment. In the respiratory process by which this substance can be eliminated. I hate her. It's okay, but it's okay. Receptors associated with aortic arch and carotid artery also can recognize change in CO2. Receptors of aortic artery and carotid arch recognize change in CO2 and H plus concentration and send signals to carotid artery supply blood to brain. Carotid artery supply blood to brain. Change also can recognize change in CO2 and H plus concentration and sends necessary signal to rhythm center for remedial actions. The role of oxygen in the regulation of respiratory rhythm is quite insignificant. Regulation of respiratory rhythm. The role of O2 is quite insignificant. Asthma, allergy is difficulty in breathing, inflammation of bronchioles, then wheezing, coughing, sneezing, something like that. Cause wheezing, nasally breathing, and inflammation of bronchi, and bronchioles. Inflammation of bronchi and bronchioles, allergy, difficulty in breathing, causing wheezing due to inflammation of bronchi and bronchioles. Emphysema is chronic disorder in which alveolar walls are damaged, due to which respiratory surface is decreased. Alveolar walls are damaged. The major cause of this is cigarette smoking. Occupational respiratory disorder in certain industries, especially those involving grinding or stone breaking. Inflammation leading to fibrosis. Inflammation leading to fibrosis. Proliferation of fibrous tissue. Proliferation of fibrous tissues. Proliferation of fibrous tissues, and thus causing serious lung damage. Workers in such industries should wear protective mask. Proliferation of fibrous tissue. Proliferation of fibrous tissues. Fibrosis. Fibrous tissue. Proliferation. Okay. Fibrosis. Causing serious lung damage. Worker in such industry should wear protective mask. Asbestosis, chronic due to inhalation of asbestos dust. Sinusitis, inflammation of mucous membrane in the nasal sinus. Sinusitis, inflammation of mucous membrane in the nasal sinus due to smoking. Chalcosis, charcoal, due to chalcosis. Diffusion, pain, 25-30%. $180. Body fluid and excretion. Plant anatomy chapter नाम क्या है? Breathing and exchange of gases, fast practice mode. How many questions? 10. 10 questions, just 10. Tick mark the incorrect statement. Every 100 ml of deoxygenated blood delivers approximately to the alveolar. Correct. Carbonic anhydrase is present in very high concentration. Correct. Loop partial pressure of oxygen in tissue helps in binding of carbon dioxide. CO2 is carried in hemoglobin as carboxyhemoglobin. Carbaminohemoglobin. This one is incorrect. Air moves into the lungs where atmospheric pressure is. Air moves into the lungs where atmospheric pressure is less than the pressure within the lungs. Air moves into the lungs when atmospheric pressure is greater than pressure within lungs. Pneumotaxic center, Pons region of the brain, ACO2. O2 dissociation, oxygen dissociation curve, hemoglobin 3. Carbonic anhydrase. Carbonic anhydrase, RBC. Primary site of exchange of gases, alveoli. Which of the following factors are favorable for the formation of oxyhemoglobin in alveoli? Low PO partial pressure of CO2 and high lesser H plus concentration. High oxygen and high PO2. High partial pressure of oxygen and lesser H plus concentration. My eyes are peeling. Blood carries the CO2 in 3 forms. Blood carries the CO2 in 3 forms. The correct percentage of CO2 in these forms are 70% carbamina, 20 to 25% carbaminohemoglobin as bicarbonate, 70% dissolve form in plasma, 7%. Correct. The presence of CO2 in blood will the presence of CO2 in blood lower will lower pH because CO2 combines with. You are giving me the pressure. मैं ना मॉड्यूल से ही क्वेश्चन सॉल्व कर सकती हूँ, मैं स्क्रीन को ज़्यादा नहीं देख सकती, मुझे आँख में दर्द होने लगता है। वैसे मुझे वो ना पीसी से ही पढ़ने में इजी होता है क्वेश्चन सॉल्व ना, लेकिन मैं क्या कर सकती हूँ, मैं अपनी आँखों को भी तो बचाना चाहती हूँ। शायद मैं आज आई ड्रॉप नहीं लगाई, इसलिए शायद ज़्यादा पेन कर रहा है। मैं कुछ नहीं दिखती। आज मैं वापस आ रही थी ना, तो वापस एक आंटी जा रही थी ना, फिर मैंने उन्हें ना देखा ही नहीं। मैंने उन्हें देखा लेकिन उनके फेस को नहीं देखा। मैं सब कुछ ब्लर दिखती हूँ, कुछ भी क्लियर नहीं दिखती। अभी भी मैंने क्योरियस किया तो शायद मैं अंधी भी हो सकती हूँ, तो फिर से मैं यहीं पर देख रही हूँ ना, एक बार ये कर लेती हूँ 10 times. The presence of CO2 in blood will lower pH because CO2 combines with. The presence of carbon dioxide in blood will lower pH because the presence of carbon dioxide in blood will lower pH because CO2 combines with. Dash with the rate of reaction increase by carbonic anhydrase. Water to form H plus and carbonic anhydrase. Which of the following statement is incorrect about transport of gases? About 97% of O2 is transported by RBC in blood, correct? 3% of O2 is dissolved in plasma, okay. 20 to 25% CO2 is trapped by RBC in the form of carb amino hemoglobin, correct. 70% carbon dioxide is carried. Carbon dioxide CO2 diffuse into blood from tissue site and pass to alveolar site in the form of carbon dioxide CO2 diffuse in blood. Carbon dioxide CO2 diffuse in blood from tissue site and pass to alveoli site in the form of carbonate 70%, bicarbonate 70%, carbamino, bicarbonate 70%, 20 to 25% carbamino, 7% dissolved state. Cutaneous. The functions is served by the tracheal system in insect. Which function? Okay. Sensation and respiration. Only respiration. Respiration is served. Function is served by tracheal system in insect. हाँ हो गया, इतना ही करो, इससे ज़्यादा किया तो मेरा आँख ही चला जाएगा. You'll be fine. Your eyes will be fine. मेरे रंगों में. Can you? I guess I can. A monotelism excretes ammonia. A monotelic. Those are aquatic fish. Marine fish? No. Yes, marine fish. They are marine fish. Bony fish, right? Arey bhai sahab. Bony fish, aquatic amphibians and aquatic insects are monotelic in nature. Ammonia is radially soluble in water, generally excreted by diffusion across body surface or through gill surface, either through body surface or through gill surface in fish as ammonium ion. A monotelic, okay. Bony fish and aquatic amphibians. Bony fish, AB से याद करो ना please. A monotelism, bony fish, aquatic amphibians. aquatic amphibians and aquatic insect. The process of excreting ammonia is a monotelism. Many bony fish, aquatic amphibians and aquatic insects are amonotelic in nature. Bony fish, it's okay, ma. It's okay. It's okay, ma. It's okay. Many bony fish, aquatic amphibians and aquatic insect. Bony fish, aquatic amphibians and aquatic insect are amonotelic in nature. Amphibians, mammals, amphibians and marine fishes. Marine fish, mammals and amphibians. Urea, we are ureotelic. We are ureotelic. Animals, amphibians, mammals and marine fish. Mammals, amphibians and marine fish. Urea, ureotelic. Ureotelic. Uric acid, uricotelic. Uric acid, uricotelic. These are reptiles, birds, land snails and insects. Reptiles, birds, land snails and insect. Produced by metabolism is converted into urea in liver. Converted into urea in liver. Released into blood. Maintain desired osmolarity. Kidney matrix. Urea retained kidney matrix. Maintain desired osmolarity. Reptile, birds, land snail excrete uric acid. Uricotelic acid. Reptiles, birds, land snail and insects. Okay. Protonephridia flame cells are okay are the Protonephridia or flame cells are the excretory structure in platyhelminthes. Some annelids. Platyhelminthes flatworms like planaria. Some annelids and rotifers. Rotifers. Okay. Protonephridia or flame cells. Protonephridia, flame cells. Planaria, rotifers, some annelids, and cephalochordate amphioxus. Amphioxus. Cephalochordate amphioxus. Branchiostoma, lancelet. Branchiostoma and lancelet ये दो नाम ही शायद गलत भी हो सकती है मुझे ये नहीं लग रहा है. Amphioxus and lancelet. Amphioxus and branchiostoma, amphioxus or lancelet. Branchiostoma, amphioxus or lancelet. Branchiostoma, amphioxus or lancelet. Amphioxus or lancelet. Amphioxus or lancelet. Rotifers, some annelids and cephalochordate amphioxus. Protonephridia or flame cells are excretory structures in platyhelminthes flatworms, example planaria. Rotifers, some annelids and the cephalochordate amphioxus. Some of the structures are mentioned here. Path Saludar, 5 years, right? Not exactly 5, 24. Na, 5 ही लगेगा. 5 plus 5 minus 3. 7 years. More or less 7 years. कोई बात नहीं, you can do it. Rotifers, some annelids and the cephalochordate amphioxus, protonephridia, branchiostoma and lancelet. Branchiostoma, lancelet. Branchiostoma, lancelet. Branchiostoma, amphioxus or landslide. Okay. Protonephridia are primarily concerned with ionic cephalopolyp platyhelminthes and protonephridiums, okay, concerned with ionic and fluid volume regulation, osmoregulation. That is osmoregulation, ionic and fluid volume regulation. Cephalochordate and some annelids. 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 Nephridia, protonephridia, or flame cells are the excretory structure in platyhelminthes, rotifers, some annelids, and the cephalochordate amphioxus. Protonephridia are primarily concerned with ionic and fluid volume regulation, that is osmoregulation. Then we have nephridia, are the tubular excretory structure of orthworm and other annelids. Nephridia, orthworm and other annelids. Malpighian tubules are the excretory. Nephridia helps to remove nitrogen waste and maintain a fluid and ion balance. Nephridia, okay. Malpighian tubules are the excretory structure of most of the insects, including cockroaches. Antennal gland or green gland, crustaceans like prawns. Antennal glands, green glands, nephridia, orthworm and other annelids. Some annelids, branchiostoma, amphioxus, landslide. Platyhelminthes like planaria, protonephridia, okay, or flame cells. Excuse me. Last thoracic and third lumbar. Last thoracic, 12th thoracic and third lumbar vertebra. Close to dorsal inner wall of abdominal cavity. Dorsal inner wall of abdominal cavity. Dorsal inner wall of abdominal cavity. Last thoracic, third lumbar. Each kidney of an adult human measures 10 to 12 centimeter in length. Kidney 10 to 12 centimeter in length, 5 to 7 centimeter in width, and 2 to 3 centimeter in thickness. 2 to 3 centimeter in thickness, 5 to 7 centimeter in width, and 10 to 12 centimeter in length. 10 to 12 centimeter in length. 10 to 12 centimeter in length, 2 to 3 centimeter in thickness, and 5 to 7 centimeter in breadth. That is width, 5 to 7 centimeter width. Thickness 120 to 170 grams. An average weight of inner concave surface of the kidney is a notch called hilum. Ureter, blood vessels and nerves enter. Renal pelvis, funnel shaped space. Renal pelvis, projections called calyces. Cortex, inner medulla. Medullary pyramids. Column of Botany. Column of Botany. 1,000,000, 10 lakh nephrons. Functional unit of kidney. 2 parts. Each nephrons has 2 parts. The glomerulus and renal tubule. Glomerulus and renal tubules. Efferent arterial. Blood carried away. Efferent arterioles. Efferent arterioles. Bowman's capsule. Malpighian body or renal corpuscle. Glomerulus plus Bowman's capsule. Malpighian body or renal corpuscle. Proximal convoluted tubule, highly coiled network. Proximal convoluted tubule, PCT, hairpin shaped, Henle's loop. Descending and ascending limb. Dissity. Collecting duct, straight tube. Renal, renal pelvis, okay, renal pelvis converts and open into the renal pelvis through medullary pyramids in the calyces. Malpighian body और इसको क्या बोलते हैं? Malpighian body or Bowman renal corpuscle. Malpighian renal corpuscle. Correct. The Malpighian corpuscle, PCT, and the city of the nephron are situated in the cortical region, Henle's loop, medullary region. Malpighian corpuscle, PCT, and the city. Henle dips into the medulla. Cortical nephron. Juxtamedullary nephron and cortical nephron. Different arterial emerging from the around the renal tubules and are called peritubular र vasa recta भन्छ. Corticalमा छ भने renal tubules, cortexमा छ भने renal tubules, medullaमा छ भने vasa recta. Minute vessels of this network runs parallel to the Henle's loop, forming a U-shaped vasa recta. Vasa recta is absent or highly reduced in cortical nephron. Efferent arterial, Bowman's capsule, proximal convoluted tubule, Malpighian body, renal corpuscle. Okay, यसमा के हुन्छ भने त पोडोसाइट सेल हुन्छ, एउटा स्क्वामस इपिथेलियम हुन्छ. पोडोसाइट फर्स्ट, देन स्क्वामस इपिथेलियम, इनर लेयर visceral. Podocyte cells, inner layer visceral, podocyte cell, outer layer parietal, simple squamous epithelium. Renal column, Bortini. Medullary pyramids, 8 to 7 present in medulla, Ayaw. Part of cortex which is present in medulla, renal column. Medulla, cortex, renal capsule. Calyx, renal artery, renal vein, renal pelvis, ureter. The human kidney produces more dilute urine when the collecting duct becomes less permeable to H2. Efferent arterial, there is vasa recta, here peritubular capillaries. Bowman's capsule, Malpighian body or renal corpuscle, proximal convoluted tubule, distal convoluted tubule, descending limb of loop of Henle, ascending limb of loop of Henle. Vasa recta, collecting duct. Nephron, blood vessels, ducts and tubules. Information. Glomerular filtration, secretion and reabsorption. Excuse me. glomerular filtration, glomerular filtration, reabsorption and secretion that takes place in different parts of the nephron. Different parts of the renal tubules called peritubular capillaries. Okay. Glomerular filtration, reabsorption and secretion. Glomerular filtration. 1100 to 1200 ml of blood is filtered by the kidney per minute. Per minute 1100 to 1200 ml of urine. 1100 to 1200 ml of urine. Okay. कोई क्या ही कर सकता है यहाँ पर ऐसी चीज़ों में. The first step in urine formation is the filtration of blood, which is carried out by glomerulus and is called glomerular filtration. On, on an average, 1100 to 1200 ml of blood is filtered by the kidney per minute, which constitute roughly 1/5 of the blood pumped out by each ventricle of the heart in a minute. 1100 to 1200 ml of blood. The first step in urine formation is the filtration of blood, which is carried out by glomerulus and is called glomerular filtration. The first step in urine formation is filtration of blood, which is carried out by glomerulus and is called glomerular filtration. The first step in urine formation is the filtration of blood, which is carried out by glomerulus and is called glomerular filtration. 1100 to 1200 ml of blood is filtered by the kidney per minute, which constitute roughly 1/5 of blood pumped out by each ventricle. Which constitute roughly one fifth of blood pumped out by each ventricle of the heart in a minute. The glomerular capillary blood pressure causes filtration of blood through three layers: endothelium of glomerular blood vessels, epithelium of Bowman's capsule, and basement membrane. On an average, 1100 to 1200 ml of blood is filtered by the kidney per minute. On an average, 1100 to 1200 ml of blood is filtered by the kidney per minute, which constitute roughly 1/5 of the blood volume pumped out by each ventricle of the heart. नहीं, इसको ना मैं 100 questions कर लेती हूँ, यही better रहेगा ना ये सब पढ़ने से. तो let me see. Are you sure you want to quit? Yes. 100 questions. Five molecules ऐसे कर लो please. I beg you, Emma. I beg you. मेरे रंग में Which of the following are accessory excretory organs? Skin, lungs, liver, sebaceous gland. Choose the correct option. Which of the following is accessory excretory organs? 1 and 4. 1, 2, 3, 4. Okay, skin, lungs. These are accessory. यहाँ पर भी दिया है ना? देखो. Other than the kidney, lungs, liver, and skin also helps in elimination of excretory waste. Skin, lungs, liver, and sebaceous gland. CO2 200 ml per minute. 200 ml CO2 per minute, and also significant quantities of water every day. Liver is this is bile lungs. Okay, largest gland in our body, secretes bile containing substances like bilirubin and biliverdin, cholesterol, degraded steroid hormones, vitamins and drugs. Cholesterol, degraded steroid hormones, vitamins and drugs. Most of the substances ultimately pass out along with digestive waste. इतना गुस्सा आता है ना. The sweat and sebaceous gland in the skin can eliminate certain substances through their secretion. Sweat produced by the sweat glands is watery fluid containing NaCl, small amount of urea, lactic acid, etc. Though the primary function of sweat is to facilitate a cooling effect on the body surface, it also helps in the removal of some of the waste mentioned above. Sebaceous gland eliminates certain substances like hydrocarbons, and waxes through sebum. This secretion provides a protective oily covering for the skin. Small amount of nitrogenous waste could be eliminated through saliva too. Under normal condition, which one is completely reabsorbed in renal tubules? Glucose. Which one is not correct? Humans, ureotelic birds, uricotelic lizard, uricotelic whale, homonotelic whale तो mammal है ना. In the descending loop of Henle, the urine is hypertonic, while in ascending limb of loop, the urine is hypotonic. एक में hyper. Descending limb is impermeable to impermeable to Na+, while ascending limb is impermeable to S2. यही सही है. Urine is hypertonic. Hypotonic side, hypotonic, right? In nephron, water absorption is maximum in PCT, DCT, ascending loop of Henle. PCT maximum मतलब PCT में उनसा max. A minute vessels runs parallel to Henle's loop forming U-shaped vasa recta is a part of efferent arteriole. Peritubular network, okay. Amniotic vessels run parallel to the Henle's loop, forming U-shaped vasa recta as part of vasa recta. Peritubular network. Proximal convoluted tubule (PCT). Reabsorption 70 to 80%, equal 3. Distal convoluted tubule (DCT). Renal corpuscle. Filtration of blood. Filtration of blood. Equal to. Formation of concentrated urine. Ionic balance. Henle's loop. Henle's loop. Formation of concentrated urine. Seco 1. Glomerulus and Bowman's capsule constitute Malpighian body. The hormone which reduces the sodium loss through urine and sweat is parathormone, vasopressin, aldosterone, calcitonin, which reduces antidiuretic hormone. Vasopressin, aldosterone. The hormone which reduces the sodium loss through urine and sweat. मैं एक चीज बार बार नहीं पढ़ सकती, क्या पागल करके रखा है ये लोगों ने मुझे. The hormone which reduces sodium, aldosterone, through the urine and sweat is aldosterone. It reduces sodium loss through urine. Through urine and sweat. It reduces the sodium and low S loss. Sodium loss. It reduces the sodium loss through urine and sweat. Aldosterone. Aldosterone. Person is suffering from poor renal absorption. Which one of the following will not help in maintenance of blood volume? Increase ADH. Increase ADH, antidiuretic hormone. Decrease glomerular filtration. Decrease तो ADH को stimulate करेगा ना. Increase atrial pressure in kidney. Atrial pressure increase करने से decrease atrial pressure in kidney. सेकेंड स्लॉट भी ओवर हो गया. पता नहीं क्या हो गया यार, ये वाला सेशन में मैं पागल हो गई. When a person is suffering from poor renal absorption, which one of the following will not help in maintenance of blood volume? Increase atrial pressure in kidney. Atrial pressure किडनी में increase करने से क्या होगा? पहले भी किया था शायद, ये सेम चीज रॉन्ग किया आज मैंने. समझ में ही नहीं आ रहा है यार, एक ही चीज बार बार करो. दस मिनट का ब्रेक लेंगे. ओके, मेरा तो दिमाग ही बंद हो गया है. ये लो 10 मिनट का ब्रेक रख दिया है. पागल हो जाओ अभी तक तो. अरे होने दो यार, यही कर सकते हैं. अच्छा लगता है. 50 मिनट लिखना था, 60 मिनट लिख दिया। ठीक है, लास्ट स्लॉट है तो 60 कर ही देते हैं। Why others? Where are you going? हाँ तुम करना 90 मिनट का स्लॉट रख के, मैं 60 मिनट के बाद जाऊंगी ना श्री, इसलिए 60 मिनट भी नहीं, 50 मिनट के बाद ही जाऊंगी, लेकिन मैंने वहां पर लिख दिया गलती से 60 मिनट। ओके, लास्ट सेशन है आदर्श, तुम कर पाओ तो ये वाला सेशन अटेंड करो, उसके बाद मैं भी जा रही हूँ। जिसे इसको पढ़ने का इरादा नहीं है ना वो खुद को पुश करो यार, लास्ट सेशन है ये। वैसे भी मैं कुछ देखती नहीं हूँ ठीक से, फिर भी कर रही हूँ मैं। तुम लोगों का तो सही है, एटलीस्ट तुम लोग देख पाते हो तो पढ़ो ना। उसका मैं कुछ बोल नहीं सकती, अभी मैंने ना बहुत सारा, एक ही बार में बहुत सारा कॉफ़ी पी लिया, I mean 2 पैकेट शायद, तो अगर उसकी वजह से नींद नहीं आई तो मैं वापस आऊँगी, लेकिन वैसे बैठने का इरादा नहीं है, क्योंकि मैं जब सुबह सोती हूँ ना दिन में तो वो इतना इफ़ेक्टिव नहीं रहता है। मुझे ऐसा लगता है कि मेरा पूरा शरीर भारी-भारी है, मैं कुछ नहीं कर पाती। मुझे ऐसा लगता है कि मैं सोई ही नहीं हूँ। कर पाए तो अच्छी बात है। ये वाला गाना गाओ ना कोई, मेरे रंग में रंगने वाली, ये ना वो गरिमा मैम ने गाया था, मैम पढ़ाते पढ़ाते गाई थी, तो मुझे भी मेरे दिल में बैठ गया ये गाना। टू पैकेट, हाँ ये तो मेरे लिए तो कॉमन है ना। आप गा लो। ओके राधे, मेरे रंग में रंगने वाली, उसके बाद मुझे लिरिक्स नहीं पता। चलो पढ़ते हैं। पानी है? नहीं है, मुझे तो प्यास लग रही है, कोई बात नहीं, ये सेशन के बाद पी लेंगे। चलो पढ़ते हैं। ओके, फिर कभी गा लेंगे। वैसे मुझे गाना बिल्कुल नहीं पसंद, मुझे 2 चीज़ नहीं पसंद, एक तो गाना, एक नाचना। पता नहीं ये मुझे बहुत ही चीप लगता है, बाय प्रोफेशन भी। ऐसा नहीं सोचना चाहिए हालांकि, लेकिन अगर मुझे ऑप्शन मिलता तो मैं ये 2 चीज़ नहीं करती अपनी लाइफ में, गाना और। वैसे मैंने एक बार मेरे दोस्त को, जिसको बहुत ज़्यादा गाना पसंद है, उसको बोल दिया था मुँह पे ही कि मुझे ये 2 प्रोफेशन बहुत चीप लगता है, गाना और नाचना। तो वो बहुत नाराज़ हो गई, शायद मैंने उसको हर्ट कर दिया, तो तुम लोग ऑफेंड मत हो जाना। बायोमॉलिक्यूल्स कर लेती हूँ ना मैं। मेरे रंग में रंगने वाली परी। गुड लक एवरीवन, गुड लक श्री। मौसम शर्मा के गालो, भाई मैं मौसम शर्मा को नहीं जानती, कोई आर्टिस्ट है क्या? जैसे मैं चैट्स को बंद कर दे रही। मासूम दादा का गाना लगाओ। अबे अपने फोन में खोल के सुन लेना, ये पढ़ाई वाला सेशन है, कहाँ से आ जाते हो तुम लोग? बच्चों के सेशन में घुस के कुछ भी लिखते हो, शर्म नहीं आता? पढ़ाई कर चुपचाप। बेशरम कहेगा। थॉरो रीडिंग ना पूरा चैप्टर कंप्लीट करूंगी 50 मिनट में, ओके। जितना समझ में आए समझ में आए, जितना नहीं आए देख लेंगे। Biotechnology principle and processes. Biotechnology deals with the techniques of using live organism or enzymes from organisms to produce products and processes useful to humans. In this sense, making curd, bread, or wine, which are all microbe mediated processes, could also be thought as a form of biotechnology. However, it is used in a restricted sense today to refer to such of those processes which use genetically modified organisms to achieve the same on a large scale. Further, many other processes techniques are also included under biotechnology. For example, in vitro fertilization leading to a test tube baby, synthesizing a gene using using it, developing a DNA vaccine, or correcting a defective gene are all part of biotechnology. फिर से एक बार पढ़ो, कुछ समझ में नहीं आया। Biotechnology deals with techniques of using live organism or enzymes from organism to produce products and processes useful to human. Okay, एक टेक्निक है जैसे enzymes या फिर live organism